G'day everyone, how are you doing? We're back here in another unit. This is our normal distribution, and honestly normal distribution, it can get tricky, and it does, but in the early stages it's quite simple. Now I want to run through some of the basic ideas about normal distribution. This video is only really intended to give you the basic idea. I'm not going to work anything out, alright? That'll come in later video. So what are we talking about with normal distribution? Well, normal's a bad word to use because what is normal these days anyway? So normal distribution is about taking a large amount of data on a topic and graphing it out. And what we find is that it always looks like this. It always looks like this. Now you could go and survey 500 people for how tall they are. It would look like this. You could go and survey people for how far their house was from where you were surveying them. It would look like this. You can go and survey how many TVs someone has in a house. It will look like this. If you survey people enough on a particular topic where there's a numerical answer coming out, you will get this. And you're probably thinking, really? Always? How can that be so? This is the reason. This is the reason. If we survey enough people, right, and that's a key thing, survey enough people. If we do, then if I work out the middle of that data, wherever it is, let's use height. I'm about average height, I'm 1.8 tall. I'm going to say I'm average height, right? Half of the people are going to be taller than me, half of the people are going to be shorter than me, okay? Now some people are going to be way up here, right? They're going to be at the extremes. Some people are going to be down here. They're going to be at the extremes either side. And in between, we get this spread happening between. Now the position of this scale along here is not always the same. And the spread of this data is not always the same either. They're the things that change depending upon who you're surveying or what you're surveying on. Okay? But we always get this coming out. Now I've written a couple of things in here. I've said that the sum of the probabilities equals 1. Because we're in probability still, the area under the curve equals 1. Okay, the area under the curve is all, that's still the same. Continuous, discrete, normal, whatever, area under the curve is 1. I've dashed down this point here saying that's the mean, right? So my height would be there. Let's put it in for me. This would be 180 centimetres here. Now someone who's 210 centimetres, they might be up here. And someone that's 150, they might be down there. And everyone else in between, okay? So the mean is that middle point, all right? So therefore, if that's the mean, and I just said half of the people are taller than me, then the area in that shaded region has to be 50%, okay? So there's some basic ideas about the idea of normal distribution for now. I want to bring one more concept in, and this is the concept of how can I split up the data here so that I can kind of get a feeling for where things are at. Well, that's where standard deviation comes in. Up until now, you've just been working it out. Now let's see what it actually means. Well, I told you this was the mean here. All right, the mean's in the middle. My other dashed lines are saying one standard deviation. So if I go this way by one standard deviation, I'm going to be here. Now I've just dotted that line in, but I'll tell you why it's there. And if I go this way, well, it's really minus one standard deviation. So I'm moving forward and back by a standard deviation. Now, like I said, it doesn't matter what we survey, we come up with the same results or the same style of graph every time. So if I do mean and standard deviation for a particular set of data, then what it ends up being is that approximately 68% of the data will fall in there. 68% will fall between the mean plus or minus one standard deviation. So we write mean plus or minus one standard deviation. Now we can work those, we can work those numbers out based on the information we get from our data. Then we know where the middle section of the data is. You'll remember this 68%, trust me, it'll be ingrained very soon. If I go to 2 standard deviations, I'm out to here, plus 2 standard deviations, or minus 2 standard deviations. Then what I find is I'm up at 95% of the population. So including this on here as well, then the mean plus or minus 2 standard deviations is 95%. If I go 3 standard deviations, that becomes 99.7. Okay? So when people say to you, if you're outside 3 standard deviations, you're quite extreme in that particular case. Now, in terms of height, let's say this is 210. I mean, you should be in the NBA or something like that. But if you're taller than 210, 220, you're falling up into this area here, you are extremely tall. You are well distinct from the majority of the population. Say, for instance, I did a survey on the distance people were from school here. Well, most people, I'm going to make the guess, are between, say, up to about 15 kilometres away. Okay? Now, that's probably encompasses most people, but I know from my school here, we have some people that jump on the train line and make it all the way down to Mandurah. So they may well be 50, 80, 100 kilometres away from the school, depending exactly where they live. Now, they would be considered quite extreme. Okay? The other example, and I know 2 students like this, the other example would be down here. That would be the student that lives across the road from the school. And we have had students that live virtually on the street that the school is on. So they would be here, their distance to home would be 100 metres, but someone else up here might be 100 kilometres. So that would give the range, and maybe the middle might be around 25 or 20 kilometres or something like that, I don't know. And that would change for every school. So if we did this for a school that was more of a local intake school, then this might be compressed right in, but still the same shape. For my school, it's probably going to be stretched a lot more. Hope those ideas helped. Good on you guys. Catch you later.